Hi guys, in this video, I'll be implementing Stack using linked list in C. Now, I'm under the assumption that you already know stack operations and pointers, so I will not be elaborating much on those notions. Without further ado, let's get started. So we have here the main source file, and I have already included the two libraries that we will be using throughout the program. The first one contains the standard input and output operations that we will be using, while the second one contains the dynamic memory management. Now first, we are going to define the structure for the node. We are only going to let it hold a single data that has a data type of integer. And then it will hold the address for the next node. Next, we are going to define a global variable that will be the pointer of the node of the topmost node in the stack. And since we are going to do stack operations, we are going to define prototype functions for each stack operation. The first prototype is for the push operation of the stack. It will accept an integer as a parameter and create a new node containing that data, then pushing it to the top of the stack. The second operation is a pop operation. This will pop the node at the top of the stack. And then the peek operation peeks the data of the top node in the stack. And lastly, the print stack routine prints the data of each node by traversing through each node of the stack until it reaches the last node. Now, before we define each of these function prototypes, let's first define the main function. So first, let's define an infinite while loop, which will contain all the operations that the user can select repeatedly without having to restart the program again and again. Now let's print the operations that are available to the user. Let's now define a variable where the choice of the user is saved to. Now that we've gotten an input from the user, let's determine using a switch statement what was the selected operation. I'm just going to go ahead and add a comment on top so it could guide me later. Now first, let's define exit. Okay, so let's try running it. And when we select number 4, it should exit the application. Let's put it up. Okay, so here's the output. What do you want to do? So we have here the different choices, 0 to 4. So let's select 4. Okay, so successful. Now let's continue. The first stack operation that I'm going to define is the push operation. So first let's head up to the define function prototypes and copy it. Okay. Now we can begin defining the definition for this function. So first let's allocate a memory for the new node. Now that the memory has been allocated, let's save the new data to this new node. Next, we are going to check if the stack is empty or not. So if the stack is empty, this is going to be the first node on the stack. However, if it is not empty, then we will set this node as the topmost node of the stack and then point this new node to the current top node of the stack. So first check if the stack is empty. Since it is empty, set the new node's pointer to the next node as null. To null. However, if it is not empty, then set the new node's next node to the current top node. And then finally, set the new node as the current top node. Now that we are done defining the function for the push operation, let's go ahead and use it in our main function. Before we use the push operation, we will need to ask an input from the user. So let's ask the user for some data that they want to save in the node. Once again, let's define a variable at the top that will hold the user's data for the node. And let's set it to 0. Now that we have the data from the user, let's push it to the stack. Okay, now we're done. Now before we go ahead and run the program, let's first define the routine that prints the stack. That is so we can see if the data that was provided by the user was successfully added to the stack. So let's go to the top and copy the function prototype for printing the stack. Let's minimize this one. Now before traversing to all the nodes within the stack, we have to make a copy of the address of the top node. We must not directly use the global variable holding the address of the top node, because in doing so, we will lose the pointer to that node. The two operations that could update the data holding the top node of the stack is the push and pop operation. When printing or picking on the stack, you should only copy the address of the top node and not try to edit it. So let's go ahead and create a copy of the address of the top node. By using a while loop, let's traverse through all the nodes in the stack until it reaches the bottom node. So traverse to the next node. Before traversing to the next node, print the data of the current. Now I'd like to add some sort of arrow in between the printing to show some kind of semblance in between values. So I'm going to check first if the current node is not the last node, then I'm going to print the arrow. I'm going to take this one, copy it, and we are going to put it right here. Now let's try to test the program. So first let's select push, which is 0, and then I'd like my first node data to be 1. Now let's check if it contains the value 1. So 3. So here it is, 1. Now let's add another data. So 0. And then I'm gonna select 2. Now I'd like to print it. So I'm going to expect that it should be 2 and then arrow 1, since this is a stack operation. Right? And there we have it. 2 and 1. This was the first data that we have entered, and then this is the second. And then let's add another one. So I'm going to add 3. And then let's print it. So 3, 2, 1. And then now let's exit. Let's continue. So let's collapse this one. So now we are done with push and print and exit. We have pop and peek. So let's go with pop. Now let's take the pop operation, pop prototype, and then let's put it here at the bottom, start defining it. To this function, we are going to take the top node of the stack and remove it, and then return the data of that node to the user. So first, let's get a copy of the address of the top node. Now let's get a copy of the data that the current top node contains. We need this variable because later we will be freeing this allocated memory. Now that we have a copy and we have saved the data, we're going to go ahead and detach the top node from the stack. So we're just going to assign the next node as the current top node. Now we are going to free the allocated memory for the detached node. This is very important because in C, there is no garbage collector. You have to manually free the allocated memory. And then lastly, we're going to return the data that we saved earlier. Now that we have defined this function, let's make a copy of this and use it in our main function. So here, pop, we're going to pop the topmost node in the stack, and then so this routine returns the node data of the node that was popped. So what we're going to do is we are going to print that data. So we are going to use the node data that we defined earlier to there, and then we're going to print it. There we go. Now let's go ahead and run the program. First, let's push something to the stack. And now let's check. So we have 4, 5, 6, 1, 2, 3. Now I want to pop 4, 5, 6. So check, pop. So popped 456. And now let's check the current stack. Let's print the current stack. Now it only contains 1, 2, 3. Let's continue. And finally, we define the peek function. So same as the others, let's go at the top of the code and copy the function prototype. And then let's define this function prototype at the bottom of the source file. Now for this peek function, we are going to take the data of the topmost node in the stack and return it to the user. Then we're going to take this one and then print the value, the return value from the peek routine. Now let's run the program again. So first, let's push some value onto the stack. Push again. Now let's print the stack. So we have here 9, 6, 3. And then let's pop 9. So we should be only expecting 6 and 3 left in the stack. So let's print. So we have 6 and 3. Let's try to peek. It should return 6. So here we have 6, which is correct. Now let's try popping all the values in the stack. So let's print it. And then let's try popping 3. So let's print it. So now, for this one, we might want to print something that determines that the stack is empty. So we're going to do that. So for print, let's go here. So before going to the while loop, let's check if the stack is empty. If it is empty, then we print a message saying that the stack is empty. If it is not empty, then we proceed with a loop. Let's copy all of this and put it inside the else condition. So now, when printing an empty stack, this should display. So let's test again. So now the stack is empty. Let's try printing it out. Okay, stack is empty. So let's try pushing some values onto the stack. And then let's print it. And then try popping all the values. So we print. So now the stack is empty. So what happens if we try to pop the stack, but the stack is empty? So now the application has crashed. That is because the variable that we are trying to access is null. It has not been allocated in memory, nor has it been initialized as a node. So before popping any node from the stack, we should first determine if the stack is empty. Let's declare node data at the top because we will be returning it. So let's copy this entire block of code inside the if condition. And then let's move node data, the declaration of node data at the top. declare it as 0. This condition will ensure that the popping operation will only apply to a stack that is not empty. So if it is empty, then it does nothing. The problem is whether the stack is not empty or empty, it has to return a value. And then the data in a node accepts both 0 and non-zero value, positive to negative value. So upon returning, it will still return a data. But how do we get it so that the method calling this routine will be able to determine that the stack it was trying to pop was empty or not? So to do that, let's make it so that the return value will signify if the pop operation was successful or not. So let's declare another variable here, is successful. So if it is successful, it will return a 0 value. Otherwise, it will return a non-zero value. So by default, I will set it to 1. And then this value will be returned to the calling function. However, when the stack is not empty and it successfully pops a node from the stack, then this value will be reassigned a value of 0. And this will be returned to the calling function. Now, what do we do with the node data? We can only return a single value. We also need to return a node data to the calling function so that the calling function will know that the pop node contains. To do that, we use a pointer, node data. And in this pointer, we will place the data of the popped node. So to do that, we remove this one, remove that, and then place that over here. Now let's update the main function. So now you're going to place the address of the node data as a parameter of the pop function. This will then contain the value of the data of the popped node. And then we are going to create a condition that will print the data that was popped. Otherwise, it will just display that the stack you're trying to apply a pop operation onto is empty. So if pop, so let's just copy this one, is equals to 0. So let's copy this. Otherwise, empty stack. Let's try running that one again. So first, let's push a value inside the stack. And then let's print it. So we have 12. Let's add another value. And then add another value. And then let's print it. Okay. So let's try peeking the value at the top of the stack. Try peeking the value of the node, top node of the stack. It's 56. Now let's try popping. Let's print it. Pop again. And then print it. Now we only have one node in the stack. Let's pop it again. So let's try printing an empty stack. Stack is empty. Now let's try popping an empty stack. So now it only displays empty stack. Okay, so there you have it. We have successfully implemented a stack operation using linked list. I hope it was helpful, and if you have any questions, please send them on the comment section below. Thanks for watching and have a great day.